Dear students, welcome to my channel. This is a model question paper 1, Concepts of Mechanical Engineering 2. Subject code is 25ME21I, second semester, 3 marks question, part C. So, name any 3 advanced coating technology. So, here there is a 3 advanced. One is a physical vapor deposition, PVD we can call it. Next one is a chemical vapor deposition, CVD we can call. Then third one is a thermal spraying. In the physical vapor deposition, what we are going to do, we have to coat it with a vaporized material and deposit on it the surface. Coming to the chemical vapor deposition, here we have to coating produce a chemical reaction and gases on the material surface. Next is thermal spray, nothing but, so we have to heat the material. It's a spray into applying surface. It is in the form of coating. And next question, explain the steps involved for heat treatment process. So before going to that, what do you mean by heat treatment process? Heat treatment process, nothing but heating and cooling the materials or metals to change their property. If you heat any material, it will change the property, right? That is the process, we call it as an heat treatment. So in that heat treatment, first one is a heating process and second one is a soaking process or holding, and third one is a cooling process. In the heating process, when the metal is heated, required a particular temperature, and each temperature should be depending upon the type of the material and process, which type of the material we are going to use and what type of the process we are going to use. Next, coming to the soaking or holding. In this, the metal we have to keep at a temperature and a specific time. Ensure the uniform temperature throughout the material. We have to maintain the temperature will be uniform throughout the process. Next will be an cooling. In this cooling, when the metal is cooled at a controlled rate, we have to cool in particular rate of the temperature. Then in the cooling method, we have done with the water cooling, air cooling, water cleaning and oil cleaning. There's a 3 type of cooling they are going to do. Why we have to use this heat treatment method in the heat involving heating, soaking and cooling to improve the property like a strength, hardness and toughness of the material. For that we are using this treatment. And next will be in highlight the advantages of carbon nanotubes engineering applications. So carbon advantages of carbon nanotubes, we can call it a CNTS. Okay. And first one is a high strength. So this will carbon nanotubes will having a extreme strength and lightweight and stronger than the steel material. It is stronger than the steel materials. Next is an excellent electrical conductivity. So it is having a better conductivity, electricity of any other than the materials. Next will be an high thermal conductivity, and it is having a good heat. High thermal conductivity, nothing but it is a good heat conduction, useful for electronic coolings. Next, it is having a lightweight, so nothing but it's very low density and ideal for aerospace and automotive applications. We are going to use this type of materials. Next will be an corrosion resistance. So it is resistant by chemical damage and corrosion. So this carbon nanotubes we can use. And next will be list steps involve additive manufacturing process. What are the steps we are going to use additive manufacturing process? One is we have to create CAD module, nothing but design a 3D object using a CAD software, and we have to convert a STL file. So whatever model we have to convert STL format for printing. Next we have to go for slicing. Slicing, nothing but we are dividing the model into a layer for slicing software. Next, fourth one we are going for printing, nothing but layer by layer. The machine build object layer by layer. Okay. And last process, it is post processing. So post processing, nothing but finishing operation like a cleaning, polishing and curing are done. Okay. And next will be an explain the basic principle of forging process. So what do you mean before going to that? So we should know what you meant by forging. Why we have to use in the forging in manufacturing process. So forging is a manufacturing process when the metal shape applying a compressive force using a tool like a hammer and presses. So in the forging, it's type of manufacturing process. So we want to get a shape of the material. So we are applying compressive force with the help we have using in the mechanical, we are using hammer and press, that we call it as in forging. So in this forging, so what we have to do in the metal usually heated to a to make it soft or plastic state. Why we have to heat the metal? To make it metal to soft and plastic in nature. After that, we have to applying a compressive force, use of hammer or press. And once you apply the compressive force on surface, the metal deform and take shape of the die or tool. Die or tool. Next, the gain the structure improves and increasing strength and toughness of the material. Okay, this forging principles based principle plastic deformation under the compressive force to obtain the desirable shape and improve the mechanical property of the metals. That for that process we are using forging process. It is the basic principle for to get a deformable material while applying a load on surface of the material to get a desirable shape, and it will give the improve the mechanical property. That purpose we are using forging. And next, define shearing in a sheet metal to examples. So what do you mean by shearing? So it is a process cutting the sheet metal by applying a high shear force using a two sharp cutting edges we can use as a blade without removing a chips. That we call it as a shearing of the shearing. Okay, so in that shearing, which method we are example we can give punching. So punching, what the purpose of you are using punching we can use it for producing holes on the surface of the sheet metal. And blanking nothing but you have to cut out the flat places from the sheet. You have to cut out the flat places from the sheet. Okay, and next, explain up milling operation. So you can also call it as an up milling operation, conventional milling. So in this up milling operation, what you have to do in the up milling operations, whatever we have to cutters rotated opposite direction form opposite direction in the workpiece of feed. So the cutters, whatever cutters they are going to use, it will be an opposite direction of the workpiece whatever you are going to feed. First, what your cutter teeth move against the feed direction. First you have to move against the feed direction. Okay, chips thickness started from 0 to gradually it will be increasing 0 to gradually. More friction occurs, the surface finish compressively rough, comparatively rough. More friction occurs, so surface finish comparatively rough. Using rough machine, once you got the rough material, using rough machine, okay, use rough machine. In the what we have to do in the up milling, the cutter and workpieces move opposite direction. Chips thickness increase gradually. Chip thickness increases gradually. For that purpose, we are using up milling operations. Okay. See, if the content is useful, please subscribe my channel and share support. Thank you.